This is describing motion and correlates to chapter 9.1 in your textbook. Your key concepts for this video are, when is an object in motion and how do we measure distance? Now to start off, I'm going to show you a video. It's a Slinky on a treadmill. And as you watch this part of the video, I want you to think about what all is moving. So, as you watched that, there were lots of different things moving, and to talk about them, first we have to talk what is motion. So when is an object in motion? So motion is simply the change in position relative to another object. That's really important. You have to have another object to know that you're moving. So for example, we've got this red square, the blue circle, and the green pentagon. If we take the blue and green shapes and move them relative to the red square, they're considered to be moving compared to that red square. But relative to each other, the distance between them and the position between them isn't changing. So relative to each other, they're not moving. So that relative to another object, that's called a reference point, and it's used for comparison. For example, this picture, you've got the balloon here, and you can see the mountain in the back. And using that mountain as a reference point, you can see that sometime between this picture and this picture, the balloon moved up. But without that reference point, you don't know that that balloon moved. So it's really important to know your reference points. So with our Slinky on the treadmill, relative to the treadmill, the Slinky was moving. Relative to the actual machine, the belt was moving around it. But relative to the belt, maybe the machine was flipping over and over and over inside of it. Relative to the sun, all of it was moving because Earth is revolving around the sun. Down in this picture, we've got this gentleman on the bike. Relative to his bike, he's not moving because he and the bike are traveling in the same direction. They've got the same position between them. But relative to someone on the street, he is moving because he's changing his distance between them. So how do we measure distance? Distance is simply the length of the path between 2 points. And in the SI system, we use the unit meter. Remember, your King Henry died unexpectedly drinking chocolate milk? 1 kilometer equals 1,000 meters. 100 centimeters equals 1 meter, so centi. 1,000 millimeters equals 1 meter, so milli to unit. These conversion rates you need to memorize. They're very important. There's one more thing I want to talk about. There's a thing called displacement. You might hear distance and displacement. They're actually different. Distance is the actual path traveled, whereas displacement is simply the shortest distance between the two. Sometimes you might hear it as the crow flies. So the shortest way between point A and B is displacement, but the path you actually travel is distance. We're only going to be working with distance, but I wanted you to be aware of the word. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.